Morning students, myself Jitendra, and today we will discuss about DC-DC converter, that is chopper. First, content introduction, application of a DC-DC converters, step down operation, waveforms for the step down converter, average value and RMS value, modes of operation, generation of duty cycle, step up chopper. First, introduction. The DC to DC converters or DC choppers are those power electronic circuits that convert a DC voltage source to another DC voltage source of different value and sometimes different polarity. Means it is used to convert a fixed DC source, a fixed DC input voltage into a variable DC output voltage or variable DC source. The DC-DC converters are implemented by the use of semiconductors like insulated gate bipolar transistor, power metal oxide semiconductor, field effect transistor, thyristor or another power controlled semiconductor device as well as diodes and LC circuits. Application of DC-DC converters. The application of DC-DC converters are first is electrical power supply for telecommunication system. Second is electrical power transmission system. It is also used in photovoltaic power generating system. It is used for switch mode power supply for electrical and electronic circuit. It is used for power factor correction for diode rectifier topologies. And last one, it is used for DC motor drive system. Now the step down operation. In the step down operation, that is the SW is the chopper switch, R is the load, and V is the input supply, and V naught is the output voltage. When SW switch is on, SW is known as a chopper. Uh, In this circuit, we use BJT, MOSFET, or IGBT. We can use in it. When we supply the switch SW, it is on, and the current is flow through the load and back to supply. And for time, and second time, if we close the switch, if we close the switch, then the current in the resistor uh, and voltage across R is equal to 0. So the total period time T equal to T1 plus T2. Waveform for the step down chopper. When the switch is on for time T1, then the waveform for input source is that it, and at T2 time the switch is off, then the voltage is 0, and uh, other the cycle is repeat. For current waveform at time T1, the current is flow in the circuit, then the current for the switch is that, and at T2 time the current is also 0, and after that cycle is repeat. Average value of the load current IA, we can denote IA or IO. Yeah, I note. So IA equal to V upon R equal to KVS upon R. VA is the voltage, KVS output voltage we note. T equal to time period, and K equal to small t1 upon capital T. Time t1 equal to switch on time, and time t equal to total time period t1 plus t2. K is called the duty cycle. K is called the duty cycle, and F is frequency. Now RMS value of the output voltage. The RMS value of the output voltage V naught equal to 1 upon T 0 to kt integrate of V naught square dt and root of this equation. So V naught equal to root of 1 upon T 0 to kt Vh square dt. V naught equal to root k Vs by solving this equation. Now the modes of operation: constant frequency operation, period time t held constant, T1 varied, width of pulse changes, pulse width modulation. Variable frequency operation, change the chopping frequency for time period t, neither T1 or T2 is kept constant, and last one is the frequency modulation. Generation of duty cycle, compare a DC reference signal with a sawtooth carrier signal. In this waveform, we can compare the DC signal with sawtooth carrier signal. In this, that is the sawtooth carrier signal. This is the reference signal. We compare it in this for time period t at the x-axis time t and y-axis equal to voltage V. That is the equation for this waveform. VR, that is a reference signal. VR equal to VCR sawtooth signal at the rate t equal to KT. VCR equal to VR upon T multiplied by KT, and K equal to VCR upon VR equal to M. We can denote VCR upon VR equal to M. That is the equation. Now the step up chopper. In step up chopper, an inductor is connected across the switch, that is a chopper, and diode D also connected across the load. We can supply the source voltage in the inductor, and the current is flow through the inductor and goes to the switch. When the switch is on, and current is back to supply. When switch is off, in second condition, we can supply the voltage across the inductor, and the current is directly flow through the diode and to the load and back to supply. That is the operation of step up chopper. A step up chopper output voltage waveform. That is the output voltage at x-axis, and that is the time of t period.